part 2 is asking us to use the second derivative to classify each point as a relative maximum, relative minimum, or neither. So I'll copy this direction and I'll go from here, okay? So, in the first video, we found critical points. We found critical values, this red and the orange that I circled. We're going to need to find the second derivative to plug them in, okay? So where is the first derivative? You see the purple line right there? That is what I'm going to take the derivative of to get the second derivative. And I'll scribble that down here. Look, I'm writing down here. What is the second derivative? Looking at this line right here. Take the derivative of what I'm highlighting in yellow. Okay, focus on that for me, okay? All right, so what's the derivative of this? That will be 6x plus 2, right? Now, what we need to do is plug in these critical values into this second derivative, okay? So if I plug in that first critical value of -1, this right there, into this second derivative, what's going to be the sign? 6 times -1 plus 2. That is -6 plus 2. Well, that is definitely negative. Negative second derivative tells us that we must be looking at a relative maximum. Why? Look, because negative second derivative is concave down. That's the graph of a concave down. And in a concave down graph, we have a max, relative max right there, okay? Now let's plug in the other critical value that we found, which was, what was it? Oh gosh, 1/3. So we're gonna plug in 1/3 into this second derivative. That will be 6 times 1/3. Hey, not bad at all, plus 2. If I divide 6 by 3, that will give me 2. So 2 plus 2 will be +4. And when we get a positive second derivative, we're looking at a graph that is concave up, like this. And that critical value must be a relative what? Minimum. So the positive second derivative tells us that this critical point must be a relative minimum. Okay, so relative minimum at 1/3, 22/27, and relative maximum at -1, 2. Okay, so that was part 2, and the second derivative test was what we really did, like half of what we did in section 3.2.